Hello everyone. In today's live, we are basically concentrating about the trigonometric identities. What are these trigonometric identities, sir? We are basically seeing the trigonometric identities concentrating on trigonometric identities are concentrating on representation of trigonometric functions and the trigonometric functions are basically used to represent different kinds of formulas with respect to the angle with respect to theta. In this concept, we can say this as the theta is going to be the reference angle of reference, where angle of reference theta is being taken in cot square theta or cot theta is also going to be true for all the values of theta. So if we are basically seeing there, we are concentrating on solving these three identities. So to solve this particular formula, we can say here as we know something as a fundamental in this right angled triangle as one of the side is considered as perpendicular side, another side is called as adjacent side, and third is called as hypotenuse side. And with respect to these three sides, we know one of the formula called as Pythagoras theorem. And the Pythagoras theorem states that the hypotenuse square is equals to other two sides addition with respect to their square. So to solve these three identities, we will be taking some more fundamentals that is going to be concentrating with respect to the trigonometric functions. That is sine theta, cos theta, tan theta, secant theta, and cosecant theta, and cot theta, where sine theta is represented with perpendicular by hypotenuse, that is AB by AC, and cos theta is represented by adjacent by hypotenuse BC by AC, and tan theta is related with respect to perpendicular by adjacent, that is going to be AB by BC, and secant theta we know it as hypotenuse by adjacent, that is related with respect to 1 by cos theta, and cosecant perpendicular, that is 1 by sine theta, and cot theta is related with respect to adjacent by adjacent by perpendicular, that is related with 1 by tan theta. So I will be using this particular formula theorem three times related with respect to three representations, that is AC square is equals to AB square plus BC square. And second time, if I will concentrate, AC square is equals to AB square plus BC square. And the third time related with respect to the third identity. So AC square is equals to AB square plus BC square. So let us understand about the first identity. We will divide on first identity. We will divide on both sides with AC square. Okay. So what we are doing with that, AC square by AC square is equals to AB square by AC square plus BC square by AC square, where we know that If the numerator and denominator are same, the result is going to be 1 there. LHS becomes 1 here. And with respect to AB square by AC square, we can write it down by AB by AC whole square plus BC by AC whole square. So AB by AC, we know it as sine theta, and BC by AC, we know it as cos theta. That is related with respect to this statement as sine square theta plus cos square theta. So the formula becomes 1 is equals to sine theta by cos, sine square theta plus cos square theta. The second formula we can say it as dividing both the sides with AB square. If we are doing this, we can see here as AC square by AB square is equals to AB square by AB square plus BC square by AB square. Again, here AB and AB are same, therefore it becomes 1 here, and B square can be written here, and AC by AB whole